In our first episode, we walked through the audio circuit for that thing. In this episode, we need to come up with a power supply. It's a straightforward bipolar supply. That means we have a ground reference at 0 volts with a positive direct current rail above that point, and a negative DC rail below it. Audio chips like this require bipolar DC power at a maximum of plus and minus 20 volts. A 48 volt DC rail is needed for phantom power. We start with an AC transformer that takes 120 volts AC from the wall and steps it down to 48 volts AC with the center tap. 24 volts AC for each side of the bipolar supply. The center tap becomes our 0 volt ground reference. By the way, we're working with voltages and currents that can kill you, so proceed with caution. After we come out of the transformer's secondary winding with 48 volts AC, we go through a bridge rectifier. This gives us 2 pulsing DC rails. From there, the pulsing DC goes through a set of electrolytic capacitors, C101 through C104, to level out the bumps. Then, the actual regulation occurs with U101 and U102, positive and negative adjustable regulators. R101 and R102 determine the output voltage of the positive regulator, and R103 and R104 determine the output of the negative regulator. In this case, we set the outputs at plus 18 and minus 18 volts DC. The resistor values are determined using a formula on the regulator datasheet. Next, each rail gets another dose of filtering through C105 through 108 to take out any remaining ripples. C109 and C110, a pair of polyester capacitors, remove any radio frequency interference sneaking in through the power rails. Diodes D101 and D102 are there to ensure that the positive and negative rails stay that way. Any negative voltage appearing on the positive rail shunts to ground and vice versa. D103 and D104 protect the regulator chips by ensuring that the output voltage never exceeds the input. Those regulators don't like to operate that way. C116 and C117 reduce output noise from the regulators. Finally, LEDs 101 and 102, in combination with current-limiting resistors R108 and R109, indicate the presence of actual voltage on each rail to show that the power supply is functioning correctly. That comes in handy when you're troubleshooting. So that's our supply for the audio chips. For the phantom power section, the entire 48 volt AC secondary winding of the transformer is used. No center tap for this supply. After filtering and rectification through capacitors C111 and C112 and bridge rectifier 2, we're left with about 70 volts DC. Additional RF and ripple filtering are accomplished by C113 and C114. Regulation is performed by a TL783 adjustable regulator. In this case, with R105 and R106, we get about 51.5 volts. That's a little more than 48, but that's okay because this is an unloaded supply. Once everything is up and running, that should end up closer to 48 volts. C118 filters out any output noise from the regulator. Additional stability is provided by C115 and R107. 48 volt phantom power must be ruler flat to prevent any noise being introduced at the mic inputs, where the audio circuit is most sensitive. Now, we can mate this up with the audio circuit and make sure everything behaves. We've added the additional components to the audio circuit to make sure phantom power works. Right now, you're hearing me through this test circuit on a condenser microphone. Now that we have the design tested and working, it's time to take a break, clean up the workbench, and get ready to make some printed circuit boards. That's for the next episode. Stay tuned.